Well, I finished the previous example, inverter in 7 nanometer FinFET technology. But when I have a look at the real implementation of that example, actually I had to call these actually three functions. Example underscore inverter underscore val, mol, and val. Um, so when you go to those ones, oh, now you can see that each of them is implemented as just a function. Oh, long line. There are long lines. Okay. Well, it's okay. However, mm, the problem is when a student try to modify his or her structure, actually he or she should recompile this entire code. That would be quite inefficient and quite boring. So anyhow, we have to introduce a certain parser to process users' input file. So although that is not an easy way, um, I spent some time and borrowed from my previous code into it. So I just to show you the very beginning of this journey. So, for example, I have prepared one input file. This input file is named as 3tier.cmd, and actually it just contains one single line. You can see that it shows the comment uh, domain, and there are some numbers for x directional, y directional, and z directional. And also we introduce a certain name of this region and the initial thickness of this silicon underscore bulk, and after that it will be saved as silicon underscore bulk. That's cgns. So now you can see that here our in our main function. So now I'm not calling these example functions anymore. I'm just calling the parser named as interpreter. So by calling this interpreter, actually we can do something. So why don't you just type this one, AngstromCraft and 3tier.cmd. Then, oh, now it is still it's a debugging mode, and first it just process the input file and find uh, 26 tokens, and after that it is analyzing the grammar. After that, now it understands this domain is a statement, and Rx equal to 46, 34, and 405, 450. And now we have a certain number. So why don't we just have a look at this is silicon underscore polygon dot cgns, and what we can expect is the initial structure just generated from our initialization. So I think that maybe we can add something starting from 0. The domain size was 450. So when we have a get this one, yes, this is 450, and the initial substrate silicon underscore bulk can be found here. Good thing is now we can change it quite easily. Why don't you just say 10 by 10 by 10, and initial thickness is just 1, and let's call it as substrate and save it as substrate.cgns. So guess what will happen? Now we will have a cube, and only at the lowest level we will have just very thin substrate. So why don't we just run once again the same problem, the same uh, code without recompiling it, but now you can see that now substrate.cgns is saved, and just to visualize it. Then just to also show certain number 10, why I'm calling 10, because the okay, okay, apply. Now the domain size is 10 by 10 by 10, and we have only the lowest level. The very first level is filled with the material substrate. Oh, so I think that it is quite convenient for my students to revise their structures. Of course, currently the implementation is only done for uh, the, the the very first statement domain, but I will implement H or deposition and something. Also, we have to consider mask and model specification. So that will be something, because we have to remember different masks and apply it to when it is called. So well, I have to spend some time, but anyway, that it seems to be a good starting point. Okay, thank you, and I will come back with more advanced examples and implementation. Bye.